Hello friends, Mr. Burrell here. We're at the end of our Solving Quadratics unit. So we're just going to go through kind of a general review of all the concepts that we've discussed as far as solving quadratic functions. I'm going to be doing some of the sample problems off of the review worksheet. That review worksheet is extra credit. I would recommend doing it. But I'll do a couple of the sample problems off of that worksheet along with a couple other problems in each section to kind of give us some review and walk through these different methods that we've discussed for solving functions that are quadratic, that have that squared term in there. Okay, so the very first topic that we discussed in this unit was solving quadratics by square root. I use this method when I have an x squared term or a p squared term or whatever, and then a bunch of numbers, like p squared minus 4 equals 20, 5x squared minus 7 equals 38. When I don't have an x term or a p term, so if there's not a p term or an x term or something like that, that's when I use the solving by square root method. When I just have the variable squared and a number, I can solve by square root. So this right here is number 1 on your review worksheet. So remember, when I'm solving quadratics by square root, I need to get this p squared business by itself. Just as if there was not a squared here, I need to solve for p, I need to get p by itself. So in order to do that here, I start by adding 4 on both sides, because that'll get rid of this negative 4 here. And I'll be left with p squared equals 24. Well, now I need to square root both sides, because the way that I undo something squared is square rooting. So the square root of 24 is either 4.9 or negative 4.9. 4.9 or negative 4.9. Remember that a quadratic function will always have two solutions. Either one solution repeated twice, 2 real solutions, or 2 complex solutions. In this case, I have 2 real solutions, 4.9 and negative 4.9. So if I were to plug both of these solutions back in for p here and square them, 4.9 squared, or 4.9 times 4.9, will give me 24. Negative 4.9 squared, or negative 4.9 times negative 4.9, will give me 24 also. That's why there's 2 solutions. So that's solving quadratics by square root. Let's do this one right here. This one is not in your review worksheet. This is just an extra example. But I have 5x squared minus 7 equals 38. So I'm again going to start with adding 7 on both sides. Get my x squared term by itself. So I'm left with 5x squared equals 45. Then I have 5 multiplied by x squared, so I'm going to divide by 5 on both sides. And I'll be left with, draw a little arrow here, x squared equals 9. 45 divided by 5 is 9. So now I have x squared on one side and a number on the other side, so I'm going to square root both sides. The square root of 9 is either 3 or negative 3. So my 2 solutions for that problem are 3 and negative 3. So that's how I solve a quadratic using the square root method. If I don't have an x term, so in my quadratics that are of this form, ax squared plus bx plus c equals 0, if this term isn't there, I can use the solving by square root method. Next, we talked about finding zeros, or the zero product property. Remember, we talked about when we're solving quadratics in a form like this, if I have this term right here, 2x minus 3, multiplied by this term right here, x minus 3, and I have them set equal to 0, common sense tells me if I'm multiplying 2 things together and the answer is 0, one of those things has to be 0. I either have like 0 times 6, or I have 17 times 0. One of those terms has to be 0 for that equation to work. Otherwise, it doesn't make any sense. I can't do like 2 times 3 and get 0, or 3 times 3 and get 0, or 100 times 3 and get 0. One of those terms has to be 0. So, in this case, I have 2x minus 3 times x minus 3 equals 0. So either 2x minus 3 has to equal 0, or x minus 3 has to equal 0. Okay, well this is just 2 linear equations where I can solve for x. So here, 2x minus 3 equals 0. I'm going to add 3 on both sides and get 2x equals 3, because this cancels out. Then I go ahead and divide by 2 and get x equals 3 halves, or 1.5, however you want to write that. So that's one of my solutions, x equals 1.5. I also had x minus 3 equals 0, because either one of these, if either one of these was 0, that would satisfy my situation here. So if x minus 3 equals 0, I'm going to add 3 to both sides and get x equals 3. So my two solutions would be 3 and 1.5. And if I plug both 3 or 1.5 back in for x in both of these expressions, you'll notice that I indeed get 0 multiplied by 0. Okay, so that was number 5 on your review worksheet. This one down here is an extra example. There's some kind of like this on your review worksheet that I want to touch on. Here, notice I have 3 terms. I have x times x minus 2 times 4x plus 6. So that's as if I had 3 things being multiplied by each other to be equal to 0. Still the same rule applies. If any of those 3 terms are equal to 0, then the product, or when I multiply all those together, the answer will be 0. So either x could be 0, x minus 2 could be 0, or 4x plus 6 could be equal to 0. Well, this is already simplified, so one of my solutions could be x equals 0. With x minus 2 equals 0, I need to add 2 on both sides, so I get x equals 2. So 2 would be one of my solutions. Here, I'm going to subtract 6 on both sides and get 4x equals 6. And then I'm going to divide by 4 on both sides and get x equals 6/4, or 3 halves, which is 1.5 if you wrote it as a decimal. So in this case, with this expression, this isn't a quadratic expression, but that's fine. We're just talking about the zero product property. I have 3 solutions, 0, 2, and 1.5. And again, if I were to plug those back in for x in each of these terms, plug 0, 0, 0, 2, 2, 2, 1.5, 1.5, 1.5, and I simplified that expression, I would get 0 on the left, 0 on the right. So that's what we're talking about when we're finding zeros. This is a method that we use in the next upcoming sections to help find our solutions. Okay. Solving by factoring. 10.3 was called solving by factoring, where we solve a quadratic expression by factoring it into 2 factors, setting it equal to 0, and using the zero product property that we discussed in 10.2. Okay, so this one is number 11 on your review worksheet. So I'm going to go ahead and put this quadratic first into standard form. Ax squared plus bx plus c all equal to 0. Because if a quadratic is set equal to 0 and I can factor it, I can use the zero product property. Notice here I have a b term, an a term, and a c term, so I can't use the solving by square root method. So my brain goes next to, okay, maybe I can solve this by factoring. So first I'm going to subtract 6 on both sides so I can get everything on the left. 14 minus 6 is 8. All set equal to 0, because now it's in this form right here. Okay, so now I want to factor this expression. Remember, Unit 9 was all about factoring. I'm going to go ahead and multiply a and c together, which is 56. I need to find 2 numbers that multiply to make 56 that add up to 18. Well, let's see. I have 1 and 56. I have 2 and 28. I have 3 and nothing. I have 4 and 14. Hey, there we go. 4 plus 14 is 18. So 4 and 14 are my 2 golden numbers here because they multiply to make 56 and add up to 18. So as I'm doing this, I have x plus 4 over 7, x plus 14 over 7, because I'm going over my dividing by my a term. This reduces to x plus 2. This doesn't reduce, so I write it as 7x plus 4. Those are my 2 factors. 7x plus 4 times x plus 2 equals 0. So I rewrote this quadratic expression right here in factored form, which means now I can use the zero product property to solve it. Because if I have two factors that are multiplied being equal to 0, if either of these factors are equal to 0, so if 7x plus 4 is equal to 0, or if x plus 2 is equal to 0, that will satisfy this equation and give me my solutions. So here I'm going to go ahead and subtract 4 on both sides, and then divide by 7. So x equals negative 4/7. That's one of my solutions. Here, let me rewrite this over here. X plus 2 equals 0. I'm going to subtract 2 on both sides and get x equals negative 2. So my two solutions are negative 4/7 and negative 2. And I'm done. If I were to plug that back in here, if I were to plug in negative 2 here or negative 4/7 and compute all this, I would get 6 on this side and 6 on this side. Or if I plugged it into this equation, I would get 0 on this side, 0 on this side, which is a way for me to double check my work. So that's how we solve by factoring. I factor a quadratic expression and then use the zero product property. Excuse me. So that was number 11 on your review worksheet. This is an extra example that we're going to go ahead and do. I have 3x squared plus 3x minus 60 equals 0. I should have put equals 0 on here. I apologize. So I'm going to want to try and factor this expression because there's an a term, a b term, and a c term. I'm going to try to factor this expression. So first, notice I have a greatest common factor between all three of these terms. So I'm going to take 3 out and be left with x squared plus x minus 20. Okay, so now I need to find two numbers that multiply to make negative 20 and add up to 1. Well, I'm gonna go through this pretty quickly. That's going to be 5 and negative 4. 5 times negative 4 is negative 20. 5 plus negative 4 is 1. So my factors are x plus 5, x minus 4. My a term is 1. So I don't have to do anything else. X plus 5 times x minus 4 equals 0 with this 3 out in front. Okay, well, I can use the zero product property here. X plus 5 has to be equal to 0, or x minus 4 has to be equal to 0. So when I solve for x in each of these mini expressions, I get x equals negative 5, and I get x equals 4. Those are my two solutions, negative 5 and positive 4. And if I were to plug those back into this original equation, I would in fact get 0. So that's solving by factoring. Okay, next we talked about the discriminant. The discriminant was this thing right here, b squared minus 4ac, when you have a quadratic expression in standard form. ax squared plus bx plus c, the discriminant is b squared minus 4ac. And we talked about how if the discriminant is positive, I have 2 real solutions. If the discriminant is 0, I have 1 real solution repeated twice. And if my discriminant is negative, I have 2 complex solutions. So the discriminant is a way for me to know, without even solving the expression, solving the quadratic, what kind of solutions I'm going to get. So here I have 8b squared plus 9b plus 9. This is number 13 on your review worksheet. So this is my a, b, and c. So my discriminant is going to be b squared, or 9 squared, minus 4 times a, which is 8, times c, which is 9. Okay, 9 squared is 81. Negative 4 times 8 times 9 is negative 288. And 81 minus 288 is 81 minus 288, is negative 207. So there's my discriminant. So what does that tell me? Well, since the discriminant is negative, that tells me that I'm going to have 2 complex solutions. Meaning they're imaginary. They're going to be i's there. So I don't know what the solutions are, but I know that those solutions are not going to be real solutions. They're going to be complex. Okay, so that was number 13 on your homework. This one is just an extra example, kind of a unique example. So I have 5x squared equals 2x. First, I need to set everything to 0. I want 0 to be on one side, so I'm going to subtract 2x on both sides. I'm going to have 5x squared minus 2x equals 0. So this is a unique situation because I have an a term, I have a b term, but I don't have a c term. That's okay. My c term is just going to be 0. So I can still compute the discriminant. My c term is just going to be 0. So my discriminant is b squared minus 4 times a times c. So negative 2 squared minus 4 times a, which is 5, times c, which is 0. Okay, well, negative 2 squared, negative 2 times negative 2 is a positive 4. Negative 4 times 5 times 0 is 0. So my discriminant is just 4. So what? What does that tell me? Well, since my discriminant is positive, that means I'm going to have two real solutions. Two real solutions. Real meaning it's a real number. It could be written as a decimal, some real decimal number. I don't know what those solutions are yet, but I could find them, and they're going to be two real solutions. So that's the discriminant. And the big reason we talk about the discriminant is because of 10.5. We use the discriminant as part of the quadratic formula. So, as a reminder, my quadratic formula, this is my quadratic formula, and this is a really handy formula that will work to solve every single type of quadratic equation. If you can't solve it by square root method, we usually go to solving by factoring. If I can't solve it by factoring, then I usually go to the quadratic formula. The quadratic formula is a formula that will solve every single type of quadratic expression. So my quadratic formula is negative b plus or minus the square root of the discriminant, b squared minus 4ac, all over 2a. And that, again, is when I have a quadratic expression in standard form, or looking like this, ax squared plus bx plus c equals 0. Okay, this is number 17 off of your review worksheet. This answer is going to have real solutions. We've talked about using the quadratic formula when there's real solutions and complex solutions. So this one's going to have real solutions. Notice here I have 8n squared minus 22 equals 0. So I have an a term, I have a c term. I don't have a b term, but that's okay. I don't have a b term, that's okay. I could solve this by square root method because I don't have a b term. But just for the sake of using the quadratic formula, I'm going to show you how we would solve this using the quadratic formula. So that means a is 8, b is just going to be 0 because there's nothing here, and c is negative 22. So the quadratic formula is negative b, which is negative 0, plus or minus the square root of b squared, which is 0 squared, minus 4 times a, which is 8, times c, which is negative 22, divided by 2 times a, which was 8. Okay, let's simplify some of these things. 0 plus or minus anything isn't going to change it, so I'm going to have plus or minus the square root of 0 squared is just 0. Then I have negative 4 times 8 times negative 22, which is a positive 704. Divided by 2 times 8 is 16. So I have positive or negative square root of 704 over 16. Well, the square root of 704, written as a decimal, is I'm going to have positive or negative plus or minus 26.53 over 16. Remember here, I'm going to have two solutions. My solutions are going to be positive 26.53 divided by 16 and negative 26.53 divided by 16. So 26.53 divided by 16 is 1.66, and negative 26.53 divided by 16 is negative 1.66. So my solutions are 1.66 or negative 1.66. And if I were to plug this back in for n here, you'd notice I would really get 0. And if you want to go through and practice that one solving it by the square root method, make sure you get the same answer. Go ahead and do that. This is just evidence that you can, even if you can solve it by square root, even if you can solve it by factoring, which usually we want to solve using those ways if we can. But if we can't, we can always solve using the quadratic formula. So that was up number 17 on your review. That one had real solutions. Number 19 on your review worksheet, this one's going to have complex or imaginary solutions. So I'll start by putting this in standard form. I'm going to add 5 on both sides. So I'm going to get 8x squared minus 5x plus 5 equals 0. This is now in standard form. I have a equals 8, b equals negative 5, c equals positive 5. Let's plug this in to the quadratic formula, and it'll give me my solutions, my answers here. My zeros is another term for that. So I have x equals negative b, so negative of negative 5, which I'm just going to write here as a positive 5, because negative of a negative 5 is a positive 5, plus or minus the square root of b squared, so negative 5 squared, minus 4 times a times c, or times 8 times 5, divided by 2 times a, or 2 times 8. Okay, let me simplify a bunch of this down so it's not so hideous. I have 5 plus or minus. Inside the square root, I have negative 5 squared. Negative 5 times negative 5 is 25. Minus 4 times 8 times 5. 4 times 8 times 5 is 160. Minus 160. Now on the bottom, I have 2 times 8, which is 16. Well, 25 minus 160 is negative 135. Let me move this out of the way. So I have 5 plus or minus the square root of negative 135 over 16. Well, shoot! I have the square root of a negative number. This negative number under here, when b squared minus 4ac is a negative number, that means the discriminant is negative, which means I have 2 complex solutions. So my solutions here, my answers here are going to be imaginary. They're going to be complex. So this negative is going to come out as an imaginary number. So there's 2 ways you can write this answer. You could write x equals 5 plus or minus I times the square root of 135 over 16. That's it. You don't have to write anything else. Or if you want to write the square root of 135 as a decimal, you can write 5 plus or minus the square root of 135 is 11.62. So you could write 5 plus or minus 11.62 I over 16. Either of those are okay. Again, with complex solutions, I'm not super concerned about you reducing it all the way down to a decimal because of the imaginary numbers. So this is as far as you would need to go. And that's number 19 on your review. That's solving quadratics using the quadratic formula with complex solutions. So that's everything. That's everything that we've discussed in this unit, all the different possible methods, all the different possible ways you can solve quadratic equations. Quadratic equations being the ones with this little squared term here. So work on this review. Again, this review will be extra credit. I'd recommend doing it because it would be really helpful for preparing for the test. You'll be taking the test either Monday or Tuesday, and then we'll get started into the next unit. But I hope you enjoyed that. I hope it was helpful, and I definitely hope you enjoyed it as much as I did.